This device will instantly transmit all information in real time to doctors throughout the world. If an emergency is detected, the physicians will immediately inform the patient through the computer system by sending appropriate messages or alarms. Currently, the level of information provided and energy resources capable of powering the sensors are limiting. While the technology is still in its primitive stage, it is being widely researched, and once adopted is expected to be a breakthrough invention in healthcare, leading to concepts like telemedicine and mHealth becoming real. Is an abbreviation for mobile health, the practice of medicine and public health supported by mobile devices, wireless healthcare. But latest international standard for body area networks is the IEEE 802.15.6. Smart body area networks. Body area network technology uses small power, low power wireless devices that can be carried or embedded inside and on the body. Such a dedicated band technology would need features such as ultra low power radio, low complexity medium access control MAC protocol for extended autonomy, enhanced robustness in the presence of interference, high security, privacy, and trust, interoperability when communicating over heterogeneous networks in the future Internet of Things, interoperable data structures and formats. And where are we? The standards people. The national standards organizations assist us in the making of European standards, international distributors, which you can also obtain ETSI standards. Where did I pull you from? Your about page. ETSI provides members with an open, inclusive, yes. Yeah, but who are you? European Standards Organization. Okay, yeah, the ESO. (1988) by the European Conference of Postal and Telecommunications in response to proposals from the European Commission. Okay, I will come back to you. What did I get here? So one of the companies that I was looking at. Okay, so that's what it was. Apologies, folks. Okay, so when I Google wide body area network and I start scrolling down, I have, that's what it was. Technologies, smart body area network. And I just opened it up and read it to you. Geeks for Geeks, scientific research, publishing. Let me zoom in a little bit. Okay. MDPI, Biomed Central, Science Direct, Hinduai, body area network examples, body area network Wban sensors, body area network applications. And as you can see from the pictures here, it's all pictures of your body connected to the internet. Then the National Institute of Health.gov for technological requirements and challenges in wireless body area networks, wireless body area networks and its application, ultra wideband area networks with a college textbook in 2019 with Springer, radio frequency wireless world IEEE 802.15.6 basics, core, tutorial, Spoint, TechSpark, Semantic Scholar, Intech Open, Sage Publications, Zurich MedTech, a fandom thing, University of Notre Dame, ResearchGate, Institute of Physics, ICI Global, Science and Information, Sci Organization, Institute of Physics again, academia.edu, network simulation tools, as I just mentioned, why those are there. There's Omnet++, NS3S I'll mention too. Secure keyed agreement schemes in wireless body area network, the cryptography that we use. And then Taylor and Francis Online, more college textbook with Springer. International Journal of Computer Science and Network Security, PhDinfo.org, Diagnostics and Interventional Cardiology, tipsmake.com, ProQuest, IEEE 802.org, which is your working group for the WPAN, the WBAN, the WSN, it's all your 802.15s, the IEEE Computer Society, Foglets, academic dictionaries. And we're still going, and not a single one of the references here has anything to do with foo-foo, religion, or anything that isn't documented by electricians, engineers, and IT professionals. Period. Diagram, architecture, health monitoring, communication, healthcare, sensor network, application, security, protocol, IoT, history, design. There's your body, 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 there's your body. Business, college, science, business, college, science, business, college, science, business, college, science. There's your body, 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 there's your body. Back on the internet. Still on the internet. Who are you people? Forgot to look that up. I don't know who you are. ICT standards. I tried that already. You just talk about how you're so special. Global ICT standards, information communication technology. Come on, just give me a basic. TSI. European Telecommunications Standard Institute, independent, development and testing of global technical standards for ICT-enabled systems. And, oh, okay. So, I'm going to double check myself here. ICT-enabled systems are... Any product or service in this study must be based on the use of software, integrated microsystems, or communications technologies. Okay, good. So I am still on the same page. Okay, so now we're in the Journal of Sensor and Actuator Networks. And for those of you that don't know, the sensor journals have their own journals. So I would look for sensor journals. You can see I've done this before for the synergists, that they can go find MDPI on their own. And right here in the front, the whole thing is sensor journals. Science and Technology of Sensors, Japan Society of Photogrammetry and Remote Sensing, Polish Society of Applied Electromagnetics, Spanish Society of Biomedical Engineering, International Society for Measurement of Physical Behavior. And these are your biosensors. They got their own journal. Okay, so done with that. And then we come back over here into the Journal of Sensor and Actuator Networks, Wireless Body Area Network, a survey on architecture, technologies, energy consumption, and security challenges. And inside here, we're going to find more metrics and a detailed way of how we route and what protocols we use, algorithms. And we're going to start getting into the type of routing that I'm going to come back on because I simply don't have the time with this. Mixed signal processors, transceivers, and receivers. And then the stars with the star topology structure and a mesh star topology structure is what we use in the body. It's reflection. So the inverted pentagram with the regular pentagram trapping our energy, our photons and our electrons and our circuits, closed loop on the inside. That's why the mesh topology is set up that way when we transduce photons and electrons at the millimeter and the nanoscale, which is why I took the synergists into plasmonics. Bluetooth is a standardized protocol for short-range communication with low energy consumption and low cost without the need for troublesome wires. Zigbee is an intelligent network used for high-level communication protocols and low-rate data transfer. This protocol is used in personal area networks, small and low power, and its technology is fixed on the IEEE 802.15.4 standard. In body sensor networks, the Zigbee protocol is encrypted with 128-bit passwords. This system is supported through the tree, star, and mesh networks. Each device must have a coordinator on it. The operating frequency is in the range of 2.4 gigahertz, and its transmission speed is 252 kilobits per second. These are metrics, folks. These are hard metrics running in and out of you for EEG and ECG. And in November 2007, IEEE research team began examining body sensor networks and developed ultra-wideband wireless technology. It is the range over at which can send data between 850 megabits and 20 kilobits per second, utilized to simultaneously observe many constantly sent physiological signals, such as ECC and EEG. For those of you that had such a difficult time for me explaining to you net-centric warfare, this is an EEG device developed by DARPA, and this is in 2012 in use with our kill box, and that kill box goes with net-centric warfare because we use EEG, and then we change the signal back and forth in order to watch you. So the 802.11 standard for wireless local area networks and general Wi-Fi technology has 4 standards, 802.11 A, B, G, and N, that run on the 2.4 and 5 gigahertz industrial, scientific, medical bands with an average coverage of 100 meters, or 100 M, I have to double check that. Wi-Fi allows users to transfer data at broadband speeds when connected to an access point or a temporary mode. And we're going to be here a while. New generations of sensors for body sensor networks and biological monitoring. The physical world to be supervised is a living body. And we're going to get into obtrusive nodes, parasitic nodes, symbiotic nodes, bio-inspired nodes, and I'll be taking people on from there. Your wireless body area networks and topologies over here. You can read the full documentation in another format, and this is, I believe, Nature, your Science Direct. Wearable wireless body area networks for medical applications. Again, this is where we pulled this from for your sensor personal device and getting into the quantum steering. Okay. And your body area network has a range. Each standard uses different frequency bands for data transmission with data rate 10 mega, excuse me. Data transfer rate, yeah. Megabits per second. Okay, just want to make sure that we're in the same page here. Megabits maximum. First one is narrowband, which operates within the range of 400, 800, 900 megahertz and 2.3, 2.4 gigahertz bands. The human body communication is another standard which operates at range of 50 megahertz. So we'll be back with that too, because we're going to be into cybersecurity. Megahertz is a unit multiplier that represents 1 million hertz. Hertz is the standard unit of frequency in the International System of Units. It is commonly used as a measure for electromagnetic radiation and vibrations such as sound. So the question is, how much hertz can the human heart take? As previously reported, the normal heart and lung sounds range from 20 to 1200 hertz. Megahertz, 1 million hertz. That's why the terahertz low power, or else your heart would explode, which is probably where a lot of you are getting confused with network engineering and don't know that we're doing this for real, that you don't know. Micro piezoelectric pulse diagnoser and frequency domain. We are decoupling you electrically and changing out your circadian rhythms at will. And then we're going to get into terahertz radiation, using the infrared to change out your DNA. And we're going to talk about the FLIR systems that are actually used with your DNA in real time. And for that, we're also going to be going back to signal-to-noise ratio inside of semiconductors with nanotechnology 6 years ago. And we're going to be then going into spectral quality and photon confinement with the engineering. And that is light matter interactions in biology 6 years ago. And then we'll be back to the radio frequency side of MEMS and other ways that we're using the metamaterials so that the new signage I have is locked in solid. Thank you for your time, everybody, this morning. Have a good day.